Hello. How are you doing, students who are doing grade 12? Here with you, you're with Zaziviela from Entertainment, reminding you that if it's the first time you're viewing our YouTube channel, please make sure that you subscribe into our channel and also like our videos. If you have any question or any comment, you can write on the comment section. So we will reply to your comment on the comment section. Okay, we are still continuing with calculus, but we are on the part where we deal with cubic function. This is the problem that we are faced with today. We are given the function f at x is equal to into x plus 2 multiplied by into x squared minus 6x plus 9, of which it can be expanded as x cubed minus 4x squared minus 3 x plus 18. Okay, here the first question given to us, we are required to calculate the coordinate of the turning point of the graph of f. Okay, so here we are required to calculate the coordinate of the turning point, of which is this, it's a turning point. Okay, so since we are working with a cubic function, when we talk of coordinate of a turning point, uh, we can also regard them as stationary points. So you can be told that you are required to calculate the coordinate of the turning point of the graph of x, or you are required to find the coordinate of stationary points. Okay, how do you find the stationary point? Since we are given f at x to be equal to x cubed minus 4x squared minus 3x plus 18. If you are required to find the turning point or the stationary point, you have to differentiate the given cubic function uh, for the first time. So it's the first differentiation of the cubic function. How do we differentiate? We take an exponent, we multiply the coefficient of x, and then we subtract 1 on the very same exponent. Here in this scenario, we see that the coefficient of x here is 1. So when you say 1 times 3, you get 3x, and the exponent is 3. So if you say 3 minus 1, you get 2. Okay, that is the rule of differentiation. Minus, and then it's 4 times 2 becomes 8x, and 2 minus 1 becomes 1. So we can leave it like this. Minus 3, we know that x has the power of 1. So it's x to the power of 1. So you say 1 times 3, you get minus 3. And then when you subtract 1 here on the very same exponent, you get 0. So any real number to the power of 0 is equivalent to 1. So it's minus 3 multiplied by 1. Okay. From there, you know that f prime of x can be written as 3x squared minus 8x plus minus 3. Okay, so we know that when we work with the stationary point, the gradient at the stationary point or the turning point is equivalent to 0. So we say f prime of x is equated to 0 at a stationary point. So we can rewrite this as 3x squared minus 8x minus 3, and you equate it to 0. Okay, so now we have to find the factors of x. So we have to factorize this. So how do we factor out this? For you to find 3x squared, you have to multiply 3x by x. Okay, so you just open these two brackets. Okay, so when you say 3x times x, you get 3x squared. So you want to find the factors. When you multiply them, they give you -3, but when you add them, they give you what? They give you -8. So this minus indicate that the factors should take different sign, and the sign of the bigger number should be negative. So factors for 3, it's -3 and 1. So it becomes -3 and +1. So to equate this to 0, so that means 3x can be equated to -1. We divide both sides by 3, divide by 3. Therefore, your x is equal to -1/3, or x minus 3 equal to 0, of which x is equal to 3. So in this stationary point, we have two x coordinates. The first one is -1/3 and the other one is 3. So we want to find the y in the y values of this coordinate, because we know the x value. We want to find the y value. How do you find the y value? You take this x value, you plug it back to the original given equation for you to find the y value. Use the input to find the output. So we want to find f of -1/3, meaning from the equation that was given to me, that f at x is equal to x cubed minus 4x squared minus 3x plus 18. What is it that am I supposed to do? Where I see x, I have to replace it with -1/3, because x is an output and y is an okay, x is an input and y is an output. So here I want to find an output where my input is -1/3. Okay, so here plug -1/3 to the power of 3. Okay, go back, scroll down a bit. Okay, -4. Where is the x? I plug -1/3, I square it. Let us go back. It's -3x, meaning it's -3. Where is the x? I plug -1/3. Also go back. Oh, it's +18. It's +18, of which is equal to, let us use this calculator of ours here. Okay, we open bracket. 1 minus 1/3 cube, okay, to the power of 3, okay, -4, open bracket, -1/3, close the bracket. Please make sure that you don't forget these brackets, because one mistake, everything can be marked wrong. -1/3. The significance of including this bracket is to make sure that when signs should change, they are changing. Okay, here it becomes 500/27. Okay, go back here, it becomes 500/27, of which is approximately equal to, let us go back, okay, it's 18.5. So it's approximately 18.5. Okay, now we want to find the output where the input is 3. Okay, so now when we see x, we plug 3. It's -4. Instead of x, I plug 3. I square it. -3. Instead of x, I plug 3. Plus 18. What is my output? Let's go back to our calculator. Okay, let's just run. Okay, where I see this one, I replace it with 3. Move. Okay, move. Delete this. replace with 3. Go back. Okay, delete. Replace with 3. Let's just check the output. Wow, the output is 0. What can you conclude about this point? The fact that you see that when you have an input being 3, the output is 0. That means this point, that is a turning point, is also an x-intercept, since an x-intercept is where y value is equal to 0. So that means here we now can conclude that, okay, this point, of which is the turning point, 3 is to 0, is also an x-intercept. But we will verify that if happens that we might be required to find x-intercept. Okay, so these are the stationary point. Okay, let's write the points, because we cannot leave it like this. By leaving like this, that means we did not answer the question. So we'll be saying minus 1 over 3. When an input is minus 1 over 3, and output is 500 over 27. Okay, and here when an input is 3 and output is 0. So these are the turning point. Okay, moving forward. Okay, here we are required to sketch the graph of f, clearly indicating the intercept with the axis and the turning points. Okay, meaning we'll use these points, of which is the turning points, but here they want us to find also intercepts. Okay, how do you find intercepts? Okay, the way of finding intercept, we have x-intercept and y-intercept. For x-intercept, okay, for x-intercept, that's where we let y to be equal to 0. Okay, let us go back to the function given to us. Okay, let us take the first one, because the first one we have already been given the factor of which is x plus 2, because the second one we have to find the factors, but the first one is much more simplified. We know the first factor, we are required to find second two factors. Okay, let us go back. Okay, so here we know that f at x is equal to, it's x plus 3, not plus 3, it's plus 2. That's x plus 2, open bracket x squared. Let me check, is the sign positive when it gets negative? So it becomes minus 6x plus 9. Okay, so we want to find x-intercept, so we let y to be equal to 0, and you know that f at x is equivalent to y. Okay, so meaning by letting y to be equal to 0, I'll get something like this. I can write it like this: x plus 2 x squared minus 6x plus 9 is equal to 0. So when I'm factoring this one, I want to find the factors of 9. When I multiply them, they should give me 9, but when I add them, they should give me what? A minus 6, provided that this positive sign tells me that signs of the factors should be the same and they should all be negative. So if you can think of 3 and 3, you know when you say 3 times 3, you get 9. When you say 3 plus 3, you get what? You get 6. So here, that means my factors will be, it's x plus 2. I know x plus 2 is a factor. So it will be x minus 3, x minus 3. You see here, if you say x times x, you get x squared. X times minus 3, you get minus 3x. Minus 3 times x, you get minus 3x. So minus 3x minus 3x, you get minus 6x. Minus 3 times minus 3, you get 9. That makes these factors be the perfect one. Okay, is equal to 0, of which is something that can also be written as x plus 2 and x minus 2 minus 3 squared. Yeah, you can rewrite this one like this, but we are not factorizing here. We just want to find what? The x-intercept. So that means x plus 2 is equal to 0, or x minus 3 is equal to 0. That means x is equal to minus 2, or x is equal to 3. Sorry. Okay. I would like to emphasize this. I would like to emphasize this. The fact that you see x minus 3 being repeated, that means here x minus 3 is an x-intercept. At the meantime, it is a turning point. So when you see a repeated factor, when you're working with cubic functions, what is it that should come in your mind? Is that, okay, one of the factor represent the x-intercept and the other factor represent the turning point. I think that one is much more clear, meaning we have minus 2 is to 0, because we are required to find the x-intercept, and the other one is 3 is to 0. Okay, so now we have all the, okay, we have x-intercept as well as a turning points, but we don't know the y-intercept. Okay, for you to find the y-intercept, okay, for y-intercept, that's where we let x to be equal to 0. Okay, the function of x of, okay, f at x is given as x cubed. Let's just go back to the function. Okay, it's x cubed minus 4x squared. Okay, minus 4x squared minus 3x plus 18. Okay, since it's the y-intercept, it's where x is equal to 0. So I want to find f of 0. So when I see x, I replace it with 0 cubed minus 4, 0 squared minus 3 times 0 plus 18. So you see that f of 0 is equal to 18. Okay. Now we know all the intercepts. We have x-intercept, we have y-intercept, and we managed to find the turning points on the previous equation, on the previous question that was given to us. So it becomes easy for us to plot the graph. Okay, how do we plot the graph? Let's plot the graph now. Okay, let's just plot the graph. Okay, let me draw this vertical line of mine. Okay, let me not, yeah, let me leave it like this. Okay, let me check, do I have a negative y-intercept? Nah, 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 no, 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 I don't have, meaning I can give myself enough space. Okay, let me erase this. Erase this. Okay. Okay, so here, yeah, this. That's how I like. Okay, here we know that at this point it's 0 to 0. Okay, moving to the right. 1, 2, 3, 4, 6. Okay, it's minus 1, minus 2, minus 3, minus 4, minus 5. 1, 2, 3, 4, 5, 6, 7. Let me go up. Okay, let me see. 8 here. Okay, my graph won't be thrown to scale. So here it's a point 0 is to 0. Let me indicate this one's 0 part. Okay, it's 1, it's 2, it's 3, 4, 5, and 6. Okay, here it's x intercept part, here it's y intercept part. Okay, here it's minus y, here it's minus x. Okay, here it's minus 1, minus 2, minus 3, it's minus 4, and minus 5. Okay, let us look at the upper part. Okay, the highest value is what? It's 18.5. Okay, meaning let me try to squeeze my points. If I say 2, 4, 6, 8, 10, 12, 14, 16, let me use 3. Okay, 3, 6, 9, 12, 15, 18, and 21. Yes, and the 24. Yes. So the space between the two terms is equal. Okay. So I have the point here, which is minus 2 is to 0. I have a point here, which is 3 is to 0. And I have the point here, because a y-intercept is where x is equal to 0. Né? So that means I have a point here. And I have a point slightly there. You see here, if I'm moving from 18 half units up, so it becomes 18.5. And here, moving from here to here, 1 -1,3 is something that can be plotted from here. Yeah, my graph is not drawn to scale, but I think you guys can visualize this. You can see what I'm trying to do. Okay, yeah, here. Yeah. Here's the point. This is a turning point. So my graph goes like this. So it goes like this. Okay, it's got here the x-intercept. And when it's reached to ish, now let's do something that not. Okay, so my graph goes like this. Okay, it goes like this. When it's reached it, that stands, turning point goes down. And when it's reached here, it stands and go up. This. So this is how my graph should look like. Yeah. So this is the graph of f. So you can label your points here. It's minus 1/3 is 2 is 500 over 27. 500 over 27 is equivalent to 18.5. So here it's 0 is to 18. Here it's minus 2 is to 0. Here it's 3 is to 0. So you can label your points for clarity, but my graph is showing everything. So that is all that was required for you to find here. The first one was stationary points, and the second one was you to plot the graph. I hope this video was helpful to every student doing grade 12. I'm looking forward to meet you in my second or in my next video.